Let's get started. Settle down. Settle down. Welcome to 3091. I'm Donald Sadoway, and I'm going to be your instructor this semester. So what I want to do today is to introduce my plans. I've got plans for you. Plans for learning. I want to talk a little bit today about those plans. Introduce myself, introduce my class, curriculum, the path forward. So let me begin by saying that 3091 is the most important class you will take at MIT. It's true. But you know, anybody who stands in front of you to lecture should say the same thing about his or her class. If they don't believe that, they shouldn't be standing in front of you lecturing. The difference is when I say it, I'm right. And it's not just an opinion. It's because of the content of 3091. 3091 is about chemistry. It's about the central science. But it's not just about any old chemistry. This isn't a class that you could take anywhere else in this country. This is the only place that you can take 3091. 3091 is solid-state chemistry. And why do we talk about solid-state chemistry? Because engineering systems are made of solids. Now, I know what you're thinking. You say, oh, it's a solid state. He's going to talk about the chemistry that constitutes his laptop computer or the chemistry that constitutes this laser pointer. And that's true. We will talk about that chemistry. But we will also talk about soft matter. We, as human beings, are chemical machines. When this hand changes shape, it is a polymer that is changing conformality. These eyes are photodetectors, band gap of about 2 electron volts. They're not made of gallium nitride. They're made of organic compounds. Inside, what supports us? It's a ceramic skeleton. So, solid-state chemistry describes life science as well. What we're going to learn in 3091 is the rudiments. I'm going to learn the rudiments. I'll say a few words about myself so you know who's standing in front of you. I graduated from the University of Toronto in chemical metallurgy. Chemical metallurgy. Came down here in 1977 to spend a year as a postdoctoral fellow, and I guess I lost track of time. Now, what's my research? My research is in electrochemistry. Electrochemistry is the most important branch of chemistry. Do you notice some theme in my professional life? See, I have tenure. So what does that mean? It means you find your passion and pursue it. You don't waste time on trivia. All right? And that's what I urge you to do. Find your passion and pursue it. So what's my passion? My passion is electrochemistry in non-aqueous media. Anything but water. Let the rest of the world work on water. Work on molten salts, ionic liquids, polymers. And what's the reason for this? This is an application. I'm in the School of Engineering. So I'm interested in environmentally sound technologies for metal production. Right now looking at titanium, iron, recycling as well. Also interested in electrochemistry as it applies to energy storage. Energy storage for mobile power. See this gal here? She's got the cell phone. She's not even looking where she's driving. And so making safe batteries out of earth-abundant, accessible materials for portable power, ultimately to drive the car with electrons, electric fuel, to eliminate this country's dependence on imported petroleum. We can do it. How? By inventing. And the way we're going to invent is to learn the lessons in 3091 that will give us the chemistry we need to invent a battery that can send that car 250 miles on a single charge and put it in a showroom for the same price as a car with an internal combustion engine. The only thing that stands between that image and where we are today is invention. And the requisite material is right here in this class. We're also looking at colossal batteries, store the grid, enable renewables, wind, solar. And then lastly, let's never forget about dreaming. So if we want to dream and imagine that man will return to the moon or maybe even go to Mars, we're going to have to be able to produce oxygen. Live like the pioneers, produce oxygen from local resources, produce structural metals, and even produce photovoltaic silicon so they can generate their own energy from local resources. And so electrochemistry is the key enabler for that as well. So now let's turn to the whole underpinning of 3091. If we take a look at the performance of engineering, any engineering system, it's a combination of the design and the construction. Now, the construction is both the workmanship and the choice of materials. Now, how do we choose materials? We choose them on the basis of their properties. So, for example, here's an application, a beverage container. This what I'm holding is made out of an aluminum alloy. It's a metal. When I was your age, they had steel beverage cans. You can take this same beverage and contain it in a glass bottle. You can contain it in a polymer bottle. Why do we make those various choices? Because they have the right mix of properties. Now, how do you determine the properties? Properties obviously are determined by the composition. We wouldn't make this thing out of sodium chloride. It would dissolve. So composition is important, but atomic arrangement is important as well. An example is half-inch thick pine board compared to a half-inch thick piece of plywood. Both pine, but the half-inch thick pine board is one solid pine board. I can take that pine board and I can fracture it if I strike it along the grain. But the half-inch thick plywood, I can't do that because it's 1/8 inch sheet pine cross-laminated. 1/8 inch north-south, 1/8 inch east-west, 1/8 inch north-south, 1/8 inch east-west. If I try to cut through that board, I can't advance the fracture. Same composition, different atomic arrangement. So the thesis of 3091 is that the electronic structure of the elements holds the key to understanding that relationship between composition, atomic arrangement, and properties. And once you have properties, that's how you make your selection. And away we go. And that's how we got the syllabus of 3091. So the syllabus has two major blocks. First block is general principles of chemistry. It's going to be about the first 5 weeks. And that's the same stuff that you get here, 511.1, 511.2, the basics of electronic structure and bonding. And then we part company. And in 3091, we dig down into solid-state chemistry.